My talk is about learning compact DNN models from embedded vision, and this is the core part of this presentation is actually the PhD work of my recent PhD graduate, Xiaomin Wu, who is moving on to Amazon very soon. And Xiaomin has been co-supervised by me and by my colleague, Professor Rong Chen at the University of Maryland, Baltimore. So this, the theme of this talk, I think, is very has a very general applicability to embedded vision systems, where we know that deep neural network models can be have great potential and are used in so many types of applications, and are of continually increasing interest to application developers. But these models are very computationally expensive, and successive generations of the models get more and more complex. And so there's a need to compress these models to make them smaller with fewer parameters, fewer operations, so that we can fit them on resource-constrained edge devices. And we want to be able to do this while maintaining as much accuracy as possible. And so the theme of my presentation, which is about pruning, is one of the major methods for doing this kind of compression of DNN models. Some of the others are also knowledge distillation, where we kind of try to systematically transfer knowledge from a larger model to a smaller model by taking some intermediate representations that can be used to train the smaller model using relevant properties of the large model. And there's also neural architecture search, which is sort of a higher level version of pruning, where we look at the overall network architecture and try to streamline the overall architecture, including the number of layers, the types of layers, and the connectivity of the network layers. And actually, some of the techniques I'll be talking about are kind of a hybrid between pruning and also having some elements of neural architecture search. But the primary emphasis is on pruning, where the goal is to strategically remove neurons or parameters from the network, and to do so in a way that has minimal impact on the accuracy. And it turns out that, in fact, we can often remove very large percentages of neurons and parameters, and with very little accuracy loss. And this can be very beneficial for embedded vision applications.